An example of elevator proxy class you will be able to find in the downloadable design patterns set of examples. Under this subfolder week 13, model view controller elevator states, it implements a lot of different functions for the elevator, and this is actually a NetBeans project. If you have NetBeans integrated development environment for Java on your system, you can just open this as a NetBeans project and be able to compile and run it. So there is a source right here under this long path right here in the system, but you can see that there is a proxy, an example of a proxy class right here. And so you can see that the proxy implements the same interface as are all of the actual elevators have. And so this is implemented as a measuring proxy, so it keeps the statistics about the passenger count. It apparently also distance travel, I think. So it counts passengers of each elevator in the system, and it also counts the distance traveled in this demonstration for this small system. So once again, this is located under the design patterns, and there is this project right here. And if you're looking for the sources under source main Java BCC week 13 MVC elevator states. So let me just run this demonstration real quick, which implements this proxy design as part of other demos. So it has a graphical user interface, and it demonstrates how to populate Java table control with information like this. And also, if you click save scenario, this button right here is required for the scenario to run. So it has some kind of implementation of simulation scenario. And what it's showing here is that we have a configuration here with one elevator. Its label is A0, and 0 indicates that it has no passengers. So when we click the run button, it's going to activate the background thread of execution, and you see that there is floor number 4 with 3 visitors initially. And what it demonstrates, it basically demonstrates the elevator being called to a specific floor, picking up these visitors as passengers, and then it takes them down to the parking garage, and these are the labels indicated by each floor. And then it lets the passengers off, and the 3 visitors get moved by this elevator from the 4th floor to the parking garage floor. Right, so this is just a demonstration using graphical user interface in Java, doing a little bit of animation of this elevator project using Java graphical user interface. So basically, these are the highlights of Proxy Collaboration. One instance of complex object is created. In our case, we're using elevator freight and elevator passenger as examples of some sort of, important classes in our system. Proxy objects contain a reference. Right here, contain reference to the single original complex object, and any operation performed on the proxy is forwarded or delegated to the underlying subject or original object. And this allows the proxy to capture the communication to each, in our case, each type of elevator before the elevator and after the elevator performs the operation. So the proxy, in our case, collects statistical data such as the passenger count and the distance traveled. So you can open this project and examine in more detail how everything works if you'd like. This is a Java project which does this demonstration. So this is important that we can have different proxy types, because the proxy design is very flexible. It just essentially, an idea of the proxy is that we have something that we can add to already existing design and be able to perform additional tasks. So remote proxy can hide the fact that another object resides in a different address space. For instance, this remote proxy could open a network connection and communicate to another computer and control the object that lives in a different address space on a different computer. A virtual proxy can perform optimizations such as creating an object on demand, and this is what we have in this next example in this handout. Both protection proxies and smart references also allow housekeeping tasks when the object is accessed. Housekeeping tasks would be, for instance, say that we have maybe some sort of network connection, and we may want to expire it. So we may want to keep it open for a while, and if there is no activity, we may decide to close it after, say, 3 minutes. And likewise, we can also optimize this with respect to using memory. For instance, we could have loaded a large image into memory, like a picture or some sort of other multimedia resource, and we may continue using it in memory, but at some point we may decide that it's no longer really being used and free up the memory, and that would be an example of a housekeeping task. So virtual proxy example here, we have images which are potentially large images that we may try to edit using an environment like Photoshop or GIMP or some other similar image editing software. And so we can have proxy for the image and we can have the real image. So in this handout, this is a C++ demo. What it demonstrates right here in the related pages, there is a sequence diagram. And so what's happening here is that the main program basically wants to use an image. So it creates a proxy. It actually creates 2 proxies right here, and even 3 proxies, 3 proxy images. And then the proxy really doesn't load anything until somebody wants to display the image. So when the new image is not being used prior to this, so the proxy image actually goes to the real image, constructs it, and the constructor of the real image loads image from disk, and then the proxy image then delegates display image to the real image class. The next time we also display image which gets loaded, but the third time we display the image that has already been loaded. So it's one of these. So instead of doing the expensive load operation, this proxy already knows that the image is already in memory, so it goes directly to display the image. So basically, it's trying to cache the information in memory and manages whether the real image has to really go to load image from disk, or just display the image that has already been dynamically loaded as a result of history here of prior operations. So this is an example of this what we call a virtual proxy, because the image management becomes virtual. So if we want to create an image but never display it, the actual image is never loaded from disk. But if we do want to actually display it, we have to load the image, but only the first time. The next time, if we attempt to display that image, the loading operation is not necessary. And Proxy is in control of this type of logic. So there are really a lot of benefits that could be provided by using proxies. So the proxies can act as contracts for accessing services. In our case, it's somewhat an example of that. Elevator is a service vehicle or service equipment, and we can use a proxy to control our equipment, and additional tasks can be verified here. Again, an example of a contract could be that after changing the direction of the elevator, say 2,000 times, we may want to signal the rest of the system that this equipment may need to have some sort of maintenance inspection, for instance. We already discussed things that can be built by proxies into proxies with respects to some sort of time expiration or date expiration, or counter being decremented, and there would be some kind of usage, limitation on the usage of the actual subject right here. So for instance, you can have a car in a system, and you can set specific expiration date, and when you want to take this car into service, you may find out that its inspection period just has expired. So you really need to take it out of service and put it on for an inspection or maintenance or both. So expired proxy terminates access to the underlying resource. So that is just one of the business requirements that could be implemented using a proxy. Measuring proxy, we already had talked about. This was originally the idea of measuring proxy for the statistics of the usage of our elevators. Remote proxies, as we discussed, would implement complex protocol to communicate with remote service, but expose that remote service as if it was a local object inside of our application. Now, these proxies can be chained together to represent combination of contracts, known as contract conjunction. So for instance, we can have a measuring proxy for our elevator, and also a proxy that has a specific expiration date, and we can chain them together in our system. So we can have an expiration proxy sitting right in between here. So expiration proxy will do its thing and delegate the call to the measuring proxy, which in turn will do its own thing to collect statistics and eventually delegate the call to the real subject of this proxy, or the real object that provides the services. So the proxies can also be used by the resource manager overseeing the pool of proxies with expiration parameters. So remember then when we started the discussion about the object pool or resource pool, it could be a pool that instead of using the concrete objects directly, it could be using a combination of a proxy, and the proxy will manage the life cycle of an actual object inside the pool, inside the object pool. So there it becomes pretty useful with a set of expiration parameters. So sometimes you want to control the life cycle of objects based on some sort of count or expiration time or date or some other signals in the system, and that could be very effectively implemented using the proxies. So again, you could potentially build everything into the actual concrete class design, but it doesn't have to be making it overcomplicated, because you can uncouple these differently oriented needs. For instance, statistics versus equipment operation. It's just nice that there is such a nice way to be able to separate these responsibilities by using separate classes. So proxy is very effective and very popular design pattern in a variety of different systems.